Welcome to Study Loop.
Okay, so we're drawing a molecular orbital energy diagram. We're trying to predict whether we expect beryllium 2 plus and beryllium 2 minus to be stable, and if we can see them existing in a gas phase. So we start off by looking at each beryllium separately. It has a 2s orbital, and because it has 2 electrons, it's going to be completely filled. There. So now we want to form our molecular orbitals. Since we have 2 atomic orbitals, we know that we're going to get 2 molecular orbitals out. And one of these is going to be bonding. It coincides with constructive interference. We call this sigma. And one of them is going to be anti-bonding. It's destructive interference, and we call it sigma star. There you go. And so I'm going to kind of color code my 2 answers in green and blue. So for this beryllium 2 plus molecule, we see that I've drawn our beryllium here with 4 electrons, and that's neutral. For the plus, we have essentially removed one of these electrons from the system. So we're only going to have 3 electrons to fill. We get to put 2 down here in this nice stable bonding orbital, and we had to put 1 in the anti-bonding to make 3. And do we expect this molecule to exist in the gas phase? That is yes, because it has 2 bonding and 1 anti-bonding. So since it has more bonding than anti-bonding, we expect there to be a bond between it. It'll be a fairly weak bond. If you did the calculation by dividing by 2, you see that its bond order is only half, but it's still a bond nonetheless. And now if we get into beryllium 2 minus, we see one issue is we need to put in 5 electrons, so the 4 that we get from the base, and then this extra electron from the minus charge, and we only have 2 orbitals, so we don't expect that molecule to be able to exist in the gas phase. It would have to fill a high energy p orbital or something of that like, but it would have more anti-bonding than bonding. Gives you a negative bond order, and another way to say that is just it would spontaneously fly apart.